Hello my scholars, you are welcome to my school channel and my name is Frank. In this video, we are going to be tackling JAMB CBT physics past question for the year 2023. Please do not go anywhere, stay with us, we'll be right back. Welcome back to my school channel. In this video, we are going to be tackling question 1 to 20. So let's begin with question 1. The property of wave shown in the diagram above is A, diffraction. So diffraction is a phenomenon that occurs when a wave, bends around the corner of an obstacle. So B, we have refraction. So refraction is the redirection of a wave as the wave moves or travels from one medium to another of different density. While option C, we have polarization. So polarization is the process of converting an unpolarized wave or light wave, into a polarized one. While D, we have interference. So interference is a phenomenon that occurs when two waves traveling along the same medium meet. So from what I've described to us, but if you look at the diagram carefully, you find out that there is kind of bending, around this obstacle. So that leaves us with option A as the correct option. Question 2. Which of the following statements regarding the application of electrical conduction via gases is or are correct? Electrical conduction in gases is applied in I, the identification of gases, II, lightning/fluorescent tube, III, photocells, IV, cathode ray oscilloscope/TV tubes. So the answer to this question is option B. Electrical conduction in gases find application in identification of gases. Different gases burn, emitting different color of light. While II also find application in II, lightning/fluorescent tube. The different colors that we see in fluorescent tube is as a result of the different gases or the type of gases that is in the fluorescent tube. Why III photocells? III photocell is not correct because photocells are sensors, and what they simply do is that they convert light into electrical signals. Then IV, cathode ray oscilloscope/TV tube. Yes. So electrical conduction in gases is applied in III, and IV. So that makes option B the correct option. Question 3. Find the tension in the two cords shown in the figure above. Neglect the mass of the cords and assume that the angle is 38 degrees and the mass M is 220 kg. Take acceleration due to gravity to be equals to 9.8 meters per second square. So in questions like this, before you can solve it, you have to draw a diagram of this question. So let's move over to the board and sketch the diagram. So we are going to transform this diagram. So we can transform the diagram into this. So this is our weight, our mass, while this is our T2, while here becomes our T1. But remember that our angle is here. So we actually need to transform this into a right angle triangle. So if we do that, here will be equal to here, alternate angles are equal. So if we transform this into a right angle triangle, we'll be having this. While here becomes our 38 degree. According to the question, so theta is equal to 38 degree. So this becomes our T1, which is here. While here, T2, this becomes our T2. So this part here becomes our weight, the mass. But we know that weight is equals to mass times acceleration due to gravity. And according to the question, mass is equals to 220 kg, times acceleration due to gravity 1.8. So multiplying this together, this will give us 2,156 Newton. So this part is 2,156 Newton. So we can actually calculate for T1 and T2. So let's start with T2. Now we know T2 and we are looking for T2 and we are giving one side of the triangle and we are giving angle. So in that case, we are giving the opposite and we are looking for the adjacent. So in that case, we are going to be using tan. So tan 38 degree is equals to the opposite, which is 2,156, divided by T2. So T2 becomes, 2156 divided by tan 38. So dividing this, we'll be having 2760 Newton approximately. Okay, so now that we've gotten the value of T2, we can as well calculate for the value of T1. Okay, and in that case, we can use any two sides. So we can decide to use these two sides, or we can decide to use these two sides, provided we know one of the angles. Okay, so T1, okay, let's go. So since we are using these two sides, that means we are using hypotenuse and opposite. Okay, hypotenuse and opposite is sine. So sine 38 degree is equals to opposite, which is 2156 divided by T2. So to get T2, T2 becomes 2156 divided by sine 38 degree. And this will be equals to 3552 Newton approximately. Okay, so our T1 is equals to, so our T1, this is T1, not T2. So our T1 is equals to 3502 Newton, while our T2 is equals to 2760 Newton approximately. So let's move over to the screen to pick the correct option. So from our calculation, the correct option is option C. T1 is 3502 Newton and T2 is 2760 Newton. So option C is the correct answer. Question 4. A missile is launched with a speed of 75 meters per second at an angle of 22 degrees above the surface of a warship. Find the horizontal range achieved by the missile. Ignore the effects of air resistance. Take G to be equals to 10 meters per second square. So let's move over to the board to solve that question. Okay, so range is given as U square sine 2 theta all over G. Okay, from our projectile. So this is a projectile question. Okay, this is the formula for finding range. Okay, so from the question we know that U is equals to 75 degree and sine, okay, and our theta is equals to 22 degree. Divide, and our G is equals to 10. Okay, so if we manipulate this, we'll be having 75 square sine 44 all over 10. So if we multiply this out, we'll be having 3907.69, okay, all over 10. Of course, if we divide by 1, we are going to be, if we divide by 10, we are going to be moving this decimal point one place to our left. So that will be equals to 390.7, okay, let's say 3.77 meter. Okay, so let's take this to the nearest whole number. So that will be equals to 391 meter, okay, to the nearest whole number. So let's move over to the screen to pick the correct answer. So from our calculation, we got 391 meter. So the correct answer to this question is option C, 391 meters. Question 5. On a particular hot day, the temperature is 40 degrees Celsius and the partial pressure of water vapor in the air is 38.8 millimeter mercury. What is the relative humidity? So let's move over to the board to solve that question. So we know that relative humidity is given as partial pressure of water, okay, at a particular temperature all over the saturated vapor pressure, okay, pressure of water at that same temperature times 100%. Okay, so from the screen we are told that the partial pressure of water is 38.8 millimeter mercury. So we are going to read off the saturated vapor pressure of water at that temperature, okay, at 40 degrees. So from the table that is given to us, the saturated vapor pressure of water at 40 degrees is 55.3. Okay, so you'll be having 55.3 times 100 over 1. So if we multiply this out, we'll be having 3,880 divided by 55.3. So if we divide out, this will be equals to 70% approximately. So let's move over to the screen to pick the correct option. So from our calculation, we got 70%. Okay, so that is option A. So option A is the correct answer, 70%. Question 6. Calculate the absolute pressure at the bottom of a lake at a depth of 32.8 meters Assume the density of the water is 1 times 10 raised to power 3 kilogram per meter cube, and the air above is at a pressure of 101.3 kilopascal. Take G to be equals to 9.8 meter per second square. So let's move over to the board. Okay, so the absolute pressure at the bottom of the lake, let's call it T, PT. So absolute pressure at the bottom of the lake is going to be pressure at the bottom of the lake plus the pressure of air above the lake. Okay, but the pressure of air above the lake we can calculate by using this formula. P is equals to H times density times acceleration due to gravity. Okay, our H here actually stands for our depth. Okay, so here we're having 32.8 times acceleration due to gravity. So this is the same thing as 1000. Okay, times acceleration due to gravity, which is 9.8. So we multiply all this together to get 321.44 kilopascal. Because of the 1000 here, we actually converted to kilopascal. Okay, so the total pressure of the absolute pressure at the bottom of the lake will now be equals to the pressure at the bottom of the lake, which is 321.44 plus 101.3. So adding these two together, that will give us 422.7 kilopascal. Okay, so let's move over to the screen to pick the correct answer. So from our calculation, the correct answer is option A, 422.7 kilopascal. Question 7. The terminals of a battery of EMF 24.0 volts and internal resistance of 1.0 ohm is connected to an external resistor 5.0 ohms. Find the terminal potential difference. So let's move over to the board to solve this question. So these are the information that are given to us according to the question. EMF 24 volts, internal resistance 1 ohms, external resistance 5.0 ohms. But we know that terminal potential difference V is given as E minus IR. Okay, where E stands for EMF and I stands for current. Okay, and small r here stands for internal resistance. Okay, but we also know that this EMF is equals to I bracket R plus small r. Okay, so here we can make I the subject of formula so that we can get the value of I since it's not given to us in the question. So I becomes E over R plus small r. Okay, external resistance and internal resistance. So let's just input our value. So this will be 24 over 5 plus 1, which is 24 over 6. Okay, so if we divide this will give us 4 ampere. Okay, so the current is 4 ampere. So we can just substitute our value into this calculation. Since we are looking for terminal potential difference, we know that our E, which is EMF, is equals to 24, then minus our current that we just calculated for is 4, bracket our resistance, internal resistance is 1. Okay, so this will give us 24 minus 4. So in this case, we'll be having 20 volts. Okay, so the answer to this question is 20 volts. So let's move over to the screen to pick the correct answer. So from our calculation, option D is the correct option, 20.0 volts. Do you know that you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and this will take you to Myschool website. There you have to download Myschool mobile app for your Android devices and Myschool software for your laptops and computer. Please go ahead and start practicing. Moving on to question 8. A lorry accelerates uniformly in a straight line with acceleration of 4 meters per second square and covers a distance of 250 meters in a time interval of 10 seconds. How far will it travel in the next 10 seconds? So let's move over to the board to solve that question. So from the screen, these are the informations that are given to us. So here we don't know the initial velocity of the lorry, but we know acceleration, we know speed, and we know time. So first of all, to solve such a question, we first of all have to calculate for the initial velocity. Okay, using the second equation of motion, which is S is equals to ut plus 1 over 2at squared. Okay, so let's input all our values. So we know that our distance equals to 250 and the initial velocity we don't know, but we know this to be equals to 10. So we'll be having 10u, okay, plus 1 over 2 times 4, which is our acceleration, then times 10 raised to the power 2. So this will give us 10u, 250 is equals to 10u plus, so 10 times 10, that is 100. So 2 here is 1, 2 here is 2. So if we multiply together, that will give us 200. Okay, so we just simply collect like terms to get the value of u. So bring our 10u here, that will be equals to 250 minus 200. So that u is equals to 50 divided by 10. So that will give us 5 meter per second. So now that we have gotten our initial velocity, we are asked to calculate the distance, okay, that how far will it travel in the next 10 seconds. So in the next 10 seconds, if this is the first 10 seconds, then the next 10 seconds will be 20 seconds. Okay, so then our t becomes 20 seconds. So we are still using the same formula to calculate for the distance. So s is equals to ut plus 1 over 2at squared. So we substitute the given value. Now that we have gotten the value of u, so we just put it here, 5 times, our time is 20 in this case, plus 1 over 2, our acceleration still remains the same, times 4 times 20, sorry, raised to power 2. Okay, so this will give us, this multiplied, that will give us 100 plus, this will give us 2 times, 20 times 20 is 400. Okay, so this will give us 100 plus 20, this times this, that will give us, okay, so if we add these two together, that will give us 900 meter. Okay, so the distance covered in the next 10 seconds will be equals to this 900, okay, minus the 250, okay, and this will leave us with 650 meter. So the distance covered, okay, in the next seconds is equals to 650 meter. So let's move over to the screen to pick the correct option. So from our calculation, we got 650 meter. Okay, that is option A. So option A is the correct option. I believe you are enjoying this content. Please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 9. The half-life of a radioactive material is 12 days. Calculate the decay constant. So let's move over to the board. So there is a relationship between half-life of a radioactive substance and a decay constant. Okay, so the relationship between half-life and decay constant is given as half-life is equals to 0.693 over your decay constant, okay, in form of lambda. So we are asked to calculate decay constant, so we just make decay constant subject of formula. So decay constant now becomes 0.693 divided by half-life. So according to the question, we are given half-life of 12. So we simply divide 0.693 by 12. And this will be equals to 0.05775 per day. Okay, per day. So let's move over to the screen to pick the correct option. So option D is the correct option because from our calculation we got 0.05775 per day. So option D is the correct option. Question 10. The number of holes in an intrinsic semiconductor is, first of all, let's get the meaning of intrinsic. So intrinsic means something natural, something inherent. Okay, like they will say in our local parlance, okay, follow-come. Okay, follow-come. So in a follow-come semiconductor, allow me to use that word. In a follow-come semiconductor, the number of holes is always equal to the number of electrons. Okay, so in that case, that semiconductor is referred to as an undoped semiconductor. So you can actually make full use of that semiconductor because the number of holes is equal to the number of free electrons. Okay, so in an intrinsic semiconductor, the number of holes is equal to the number of free electrons. Okay, and that gives us option C. The number of holes in an intrinsic semiconductor is equal to the number of free electrons. So option C is the correct option. Question 11. Name the type of equilibrium for each position of the ball. So let's begin with ball C. So for ball C, on slight displacement of ball C will move away from its original position and go to a new position and rest there. So such type of equilibrium is referred to as neutral equilibrium. So for bulb B, now if you look at bulb B carefully, bulb B is in a slope. So slight displacement, bulb B will still return back to its original position. So such type of equilibrium is referred to as stable equilibrium. That leaves us with bulb A as being unstable equilibrium. Slight displacement, it will move away from its original position. So the correct option to this question is option D. Question 12. Rainbow formation is as a result of the combination of which of the following phenomena? I, reflection, II, dispersion, III, total internal reflection, IV, refraction. So the three phenomena involved in rainbow formations are dispersion, and that is the reason why we see those 7 colors. Okay, why dispersion, we have total internal reflection, and we have refraction. So that leaves us with option C as the correct option. Question 13. The surface temperature of a swimming pool on a warm day is 25 degrees Celsius, and the temperature at the bottom is 15 degrees Celsius. If the swimming pool has a surface area of 620 meters square and a depth of 1.5 meters, find the rate at which energy is transferred by conduction from the surface to the bottom of the swimming pool. Thermal conductivity of water K is equals to 0.6071 watts per meter per Kelvin. So let's move over to the board to solve that question. So these are the information that are given to us according to the question. So we know that thermal conductivity is given as P times L all over A times change in temperature. Okay, where P stands for the rate of energy transfer, L here could stand for distance or depth. Okay, while A stands for area of the surface in question, while delta T stands for change in temperature. So let's quickly sort out our delta T. So delta T is equals to theta 2 minus theta 1, okay, which is 25 minus 15, and that will leave us with 10 degrees Celsius. So since we are looking for rate of energy transfer, that means we are going to make P the subject of formula. Okay, so if we cross multiply, we're having PL is equals to K times area times delta T. Then we divide both sides by L to make P the subject of formula. So P becomes K times A times delta T divided by L. So let's put in our formula. So we know that our K, according to the question, which is our thermal conductivity, is 0.6071 times area is 620, then times change in temperature, which is 10 degrees, divided by 1.5. Okay, so if we multiply all the numerator and divide by the denominator, our answer will be equals to 2509.355 watts. Okay, so we have to convert this to kilowatts by dividing by 1000. So if we divide by 1000, this decimal point, we just move it 3 places to our left. So that will be 1, 2, 3. So that leaves us with 2.5 kilowatts. Let's move over to the screen to pick the correct option. So from our calculation, we got 2.5 kilowatts. Okay, and 2.5 kilowatt is option A. So the correct answer to this question is option A, 2.5 kilowatts. Question 14. Which process is responsible for the production of energy in stars? A, we have nuclear reaction. B, nuclear fission. C, nuclear fusion. D, radioactive decay. So the process responsible for the production of energy in the star is nuclear fusion. Okay, so in nuclear fusion, 2 lighter nuclei come together to form a heavier one. So in this process, matter is destroyed, but this matter that is destroyed is converted into energy. Okay, that is the energy in the star. So that leaves us with option C as the correct option. Question 15. How much network is required to accelerate a 1200 kg car from 10 meters per second to 15 meters per second? So let's move over to the board. So according to work energy theorem, work done is equals to change in kinetic energy. Okay, because from this question we are giving initial velocity and we are giving final velocity, which will bring about a change. Okay, so we know that, so this is equals to 1 over 2 mv square minus 1 over 2 mu square. So we'll bring out what is common, which is 1 over 2 m, then bracket open, v square minus u square. Okay, so if we put in our value, we'll be having 1 over 2 times 1200 bracket 15 square minus 10 square in bracket. So 2 here is 1, 2 here is 600. So we'll be having 600 bracket. Now if we tidy up what we have here, of course 15 square is 225. Okay, and 10 square is 100. So 225 minus 100, that will leave us is 125. Okay, so if we multiply these two, we'll be having 75,000. Okay, 75,000 watt. Okay, 75,000 watts. So if we put this in standard form, we'll be having 1, 2, 3, 4, which is equivalent to 7.5 times 10 raised to the power 4 joule. Okay, for joule. So let's move over to the screen to pick the correct option. So from our calculation, the correct option to this question is option C, 7.5 times 10 raised to the power 4 joule. Question 16. A wire of radius 0.2 millimeter is extended by 0.5% of its length when supported by a load of 1.5 kg. Determine the Young's modulus for the material of the wire. Take G to be equals to 10 meters per second square. So let's move over to the board. So from the information given to us on the board, we know that the length is not given to us. So let the length be equals to X. Okay, and the extension they said is 0.5% of length. So in this case, we're having 0.5 over 100, which is 0%, times X. So this will give us 0.005x. Okay, so we know that Young's modulus Y is equals to stress over strain. Okay, and the stress is force over area, and strain is extension over length. So let's tie this up. We'll be having F over A times L over E. Okay, so that Young modulus is equals to FL all over AE. We can substitute the given data into this formula. But let's convert this to meter. Okay, because everything must be in their basic unit. So let's convert this to meter. So to convert this to meter, we'll simply divide by 1,000. So we divide this by 1,000. That will leave us with 2 times 10 raised to the power minus 4. Okay, meters for the radius. And we know that area is equals to pi r squared. Okay, so we are going to be using that here. So let's substitute. Now our force, we are giving load. Okay, so to get our force is the same thing as weight here. So in that case, it's going to be W is equals to mg. So that weight is equals to 1.5 times 10. So that will be 15 newtons. So our force equals to 15 newtons. So we'll put these values here. So this will be equals to 15 times the length, which is x, all over area, which is pi, times the radius square, which is 2 times 10 raised to the power minus 4 in bracket square, then times extension, which is 0.005x. So s, we cancel out s, so that we are now having 15 over pi times, so this will be equals to 4 times 10 raised to the power minus 8, okay, times 0.005. So if we sum this up, our answer will be equals to 23873241463.784. So we put this in standard form. Okay, so to put this in standard form, we just move the decimal point to our left. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this leaves us with 2.4 times 10 raised to the power 10 Newton per meter square. So let's move over to the screen to pick the correct option. So from our calculation, the correct option to this question is option A. 2.4 times 10 raised to the power 10 Newton per meter square. Question 17. A man swung an object of mass 2 kg in a circular path with a rope 1.2 meter long. If the object was swung at 120 rev per minute, find the tension in the rope. So let's move over to the board to solve this question. So this question is a problem on circular motion, and what they're actually asking us here is to calculate centripetal force. Okay, and we know that centripetal force F is equals to mv squared all over r. From the information given to us in the question, m is equals to 2 kg. Okay, length of the rope represents the radius of the circle, which is 1.2 meter. Then F represents the number of revolution, okay, which is 120 revolution per minute. Okay, so we have to convert this to revolution per second by simply dividing the 120 by 60. So that will give us 2 revolution per second. Okay, but from this question we don't know V, but we know that V is equals to WR. Okay, so we can substitute the value of V into this equation. That leaves us with M bracket open W omega the r square, okay, all over r. So this will be M times W square times r square all over r. So one arrow will take out an arrow here. So that leaves us with M times W square, okay, times r. Okay, so our F is equals to M times W square times r. But remember that omega is equals to 2 pi F. Okay, so we substitute this into this equation, so that 2 times pi times 2, that will leave us with 4 pi. So we just substitute this into our original equation to calculate for the tension in the rope. So we know that mass is equals to 2 times 4 pi, okay, all squared, then times 1.2. Okay, so multiplying this out, our answer will be equals to 379 approximately. Okay, 379 Newton approximately. So let's move over to the screen to pick the correct option. So from our calculation, we got 379 Newton. Okay, so the answer to this question is option D, 379 Newton. Question 18. A 200 kg load is raised through a 110 meter long lever as shown in the diagram above. The load is meter from the pivot P. If the efficiency of the lever is 80%, find the effort E required to raise the load. Take G to be equals to 10 meters per second squared. So let's move over to the board. So from the information given to us in the question, we know that efficiency is given to us to be equals to 80%. Okay, we are asked to look for efforts required to raise this load. Load here, they're actually referring to force. Okay, since we know that weight is equals to mg, okay, which is also equals to force. So this will be equals to 200 times 10. So that will give us 2000 Newton. Okay, so our load L is equals to 2000 Newton. Okay, now distance moved by load as measured from the pivot, okay, is equals to 10. So DL is equals to 10 meter. Now for us to get the distance moved by effort, it will be 110, which is the length of this material, okay, minus 10. So that our DE is equals to 100 meter. Okay, but remember that efficiency is equals to load times distance moved by load over effort times distance moved by effort times 100%. Okay, so let's substitute our given value. So we know that our efficiency is equals to 80, then load is 2000, then times distance moved by load, which is 10, over effort, what we are looking for, then times distance moved by effort, which is 100. Okay, times 100 over 1. So 100 here, we cancel out 100. Okay, so that 80 is equals to 2000. So this will multiply to give us 20,000. So 20,000 over E. So we just cross multiply. So to get the value of E, we just divide by 80. So if we cross multiply, we're having 80E is equals to 20,000. So that E is equals to 20,000 divided by 80. Okay, so 0 here is 0, we cancel out 0. 8 here is 1. 8 into 20, that will be 2. Remainder 4. Put the 4 here. 8 into 4, which is 40 now. So 8 into 40, that will give us 5. Then 8 into 0, that will give us 0. So this will give us 0 Newton. Okay, so the effort required to raise the load is 250 Newton. So let's move over to the screen to pick the correct option. So from our calculation, we got the effort required to raise the load or to lift the load to be equals to 250 Newton. Okay, so the correct option to this question is option A, 250 Newton. Do you have any question to ask? Please feel free to ask your question by clicking on the link in the description below, and this will take you to my school website. There you can ask your questions and solution will be provided within a short period of time. Moving on to question 19. An air bubble of radius 4.5 centimeter, initially at a depth of 12 meter below the water surface, rises to the surface. If the atmospheric pressure is equal to 10.34 meter of water, the radius of the bubble just before it reaches the water surface is, let's move ahead and solve this question. So this is a typical question where we need to apply Boyle's law. Okay, so we know that P1 will be equals to the atmospheric pressure plus the depth of the water, okay, which will give us 22.34 meters. Okay, then P2 will be the atmospheric pressure, which is 10.34 meters. Okay, now we are looking for radius and we need to get V1 and V2. Okay, but since our bubble is fair in shape, then we'll make use of the volume of a sphere, which is 4/3 times pi r1 cube, while for V2 will be 4/3 times pi r2 cube. Okay, so here we just substitute our value for the radius, which is 4/3 times pi times 4.5 raised to power 3, and here we have 4/3 times pi times r2 raised to power 3. Okay, so using Boyle's law, we'll have P1 V1 is equals to P2 V2. So we substitute the given value. So our P1 is 22.34, then times the volume 4/3 times pi times 4.5 raised to power 3 is equals to 10.34 times 4/3 times pi times r2 raised to power 3. So 4/3 we cancel out 4/3, pi we cancel out pi. Since we are looking for r2, so r2 cube will now be equals to 22.34 times 4.5 raised to power 3 divided by 10.34, and this will be equals to 196.88. Okay, now since we are looking for the value of r, not r cube, then we take the cube root of both sides. So the cube root of r2 raised to power 3 will be equals to the cube root of 196.88. So cube root we cancel out roots, and so that r2 is equals to 5.82 centimeter. So the radius of the bubble as it rises to the surface of the water is 5.82 centimeters. So let's move over to the screen to pick the correct answer to this question. So from our calculation, we got the radius of the bubble to be equals to 5.82 centimeter, which is option D. So option D is the correct answer. Do you have better explanation or steps to any of this question? Please share this information. All you need to do is to go to the comment section below, comment the question number and the solution you wish to share. Question 20. A parallel plate capacitor separated by an air gap is made of 0.8 meter square thin plates and 20 millimeter apart. It is connected to 120 volt battery. What is the charge on each plate? Take E naught to be equals to 8.85 times 10 raised to power minus 12 farad per meter. So let's move over to the board to solve this question. So that question we are asked to calculate the charge on each of the plates. Okay, so but before we can get the charge on each of the plates, we need to calculate for the capacitance of the capacitor. And this is given as C is equals to E naught times area all over D. Okay, so this our D is diameter, so we have to convert it to meter. So converting this to meter, we will divide by 1000, and this will be equals to 0.02 meter. Okay, so that all the units can be the same, all the units can be in their fundamental unit. So let's substitute this into the given formula. So C is equals to 8.85 times 10 raised to the power minus 12 times 0.8, okay, for our area, divided by the diameter, which is 0.02. So I'm going to put this, the denominator in standard form. So this will be equals to 8.85 times 10 raised to the power minus 12 times 0.8 all over 2 times 10 raised to the power minus 2. Okay, so if I multiply this out, I'm going to be having 7.08 times 10 raised to the power minus 12 divided by 2 times 10, okay, raised to the power minus 2. Okay, so 2 here, 1, 2 here is going to give us 3.54 times 10 raised to the power, applying law of indices. So this will change to minus, so I'll be having minus 10. Okay, so this gives us minus 10 farad. Okay, but we are asked to calculate the charge on each plate, and we know that quantity of charge C is related to capacitance by CV. So we just substitute our values to get the value of Q. Okay, so Q is now, C is 3.54 times 10 raised to the power minus 10, then times 120, which is the given voltage. And this will be equals to 4.25 times 10 raised to the power minus 8 coulomb. So this is also equal to 42.5 times 10 raised to the power minus 9 coulomb. Okay, so that this is the same thing as say 42.5 nano coulomb. Okay, raised to the power minus 9 means nano. So this becomes our final answer. So let's move over to the screen to pick the correct option. So from our calculation, we got 42.5 nano coulomb, which is option B. So the answer to this question is option B. I believe you are enjoying this video content. If so, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video.